Hi St. Simon, we're going to do a little task that will hopefully reinforce your understanding of variables, expressions, and equations here in Chapter 8 of your math. Now at this point in the unit as well as the year, we have all had experience using variables to help us represent unknown quantities. We have had experience using tables of values to help us identify pattern rules. We have been able to describe the relationship between a term number and a term value on that table of values, absolutely. We've been able to create an algebraic expression with variables to represent that pattern rule. And we have also asked a question about our pattern rule and answered it by solving an equation and substituting variables. Okay, so this is all the knowledge that we currently have within us. Okay, so what we're going to do now is create a pattern using some colored paper tiles. And in creating this pattern, we're going to hopefully find where the algebra is in all of this, okay? So I have decided to pick a random letter out of the alphabet, and I have picked the letter T. And I constructed the letter T using these 5 blue tiles, okay? So that is my first figure. Now what I want to do now is grow this T out a little bit. So I'm going to start off again with those 5 blue tiles, and I'm going to add 2 more here on the top left, 2 more here on the top right, and 2 more here at the bottom. So now we have a slightly larger T, okay, in comparison to our first one there. Now, the third round, what I'm going to do is, again, begin with these 5 never-changing constant blue tiles, and I'm going to add 4 more red tiles here on top, and I'm changing the color so you can see exactly what's being added and what is remaining the same. Okay, 4 more here on the top right, and 4 here at the bottom, like so. 1 more. Okay, so now we have an even bigger T. Okay, so this was our third T, there's our second, and there's our first. You can clearly see that the blue T composed the 5 blue tiles is within each one of them. Now at this point, we can create a table of values, take what we know, and try and find the algebra in all of this. So our first column, we're going to call it figure number. We're going to let the variable n represent any figure number that we will create. And our second column will be entitled total number of squares, and we're going to let the variable s represent the total number of squares. So here are our variables. Okay, so in figure number 1, we have 5 blue tiles. So we're going to write down here total number of squares in figure number 1 is 5. Now in figure number 2, we have those 5 blue tiles. So we're going to write that down. Okay, because in figure number 2 is figure number 1. We have those 5 blue tiles, and we're going to be adding 2, 4, 6 red tiles to it for a total now of 11 total tiles. Okay? In figure number 3, we have those 11 squares or tiles from figure number 2. So we have those 11. So here on our table of values, we're going to write down 11 tiles from figure number 2. And we have added another 2, 4, 6 red tiles, for a total now of 17. So in figure number 3, we've got 17 total squares. In figure number 2, we have 11 total squares. And in figure number 1, we have 5 total squares. So you can clearly see that one pattern rule is that the total number of squares is increasing by 6. But if you do a little bit of guess and check, you need to determine the relationship between the figure number and the number of squares. What is happening to the figure number to produce total number of squares? What is the relationship between n and s? Well, if you multiply your figure number by 6 and subtract 1, it will produce 5 squares. If you multiply figure number 2 by 6 and subtract 1, it'll produce 11 squares. If you multiply figure number 3 by 6 and subtract 1, it'll produce 17. 3 times 6, 18, minus 1, 17. 2 times 6, 12, minus 1, 11. 1 times 6, 6, minus 1, 5. So our rule now using variables would be 6n minus 1 equals s. Okay, so the figure number times 6 minus 1 gives us total number of squares. This is our algebraic expression. Now, we're going to pose a question to this pattern. We're going to say, well, if this is the rule, then instead of extending this table of values, and instead of using more colored tiles or squares, how many squares or tiles would be needed to create figure number 11 without extending the table or continuing to build? So we're going to use this rule here, 6n minus 1, to answer this question here. So we're going to start off with our rule, 6n minus 1, okay? N in this case is going to be 11, okay? This will help us determine how many squares will be needed. So 6 times 11, we put this in brackets because of order of operations, multiplication of course comes first, minus 1. So 6 times 11 is 66, minus 1, 65. Therefore, 65 squares will be needed to create figure number 11. Okay? And there's the algebra.